Hello and welcome back to Calculus 3. We are starting chapter 15, which will introduce us to multivariable functions. It will introduce us to derivatives of multivariable functions. We'll do continuity, limits, all of the good stuff that you guys did in Calculus 1. But now Calculus 1 was in R2. Calculus 3 obviously will be multivariable. Now we are focusing on thru-dimensional functions, but you can go into higher dimensions, and most of the formulas and things that we develop would work in higher dimensions as well. So we want to stay within 3D, and then we'll peek here and there into 4D as we go, because you might want to think about this cell phone getting hot because you use it, and then you want to know the temperature distribution. So you have the cell phone, which is a thru-dimensional object. You need to have thru-dimensional function to describe the spatial bounds of the cell phone, and then you will have another variable on top of it, which is, let's say, capital T, which would be the temperature distribution along different parts of the cell phone, let's say. So in that case, you have 3 dimensions of space and a 1 dimension of temperature. That's a 4D space. Now you are used to 4D space as a space-time because you know where this location in space is, because you have the address and you have the floor, which is elevation. So that's equivalent. That's the easy equivalent of having a 3D coordinates of where you are in the universe right now. And you also have time, because you have to have those 3 spatial coordinates right, which means you are in the chair you are, but you also have to have the time component correct. Otherwise, you'd be here at, let's say 3 a.m. and there's no one else here. So in order for you to be here, you are perfectly able to operate in this space-time 4-dimensional entity, which is 3 dimensions of space and 1 dimension of time. So none of these concepts, right, should be foreign at this time, because you live on this planet and you've seen things. But we would like to put more of a concrete mathematical language, right? Use concrete mathematics language to develop these things. So the first thing that we are going to do is we are going to define a function, the multivariable function in space, and this one will have 2 independent variables. So if you studied carefully, right, in Calc 1 and obviously pre-calculus, you learned that function is a rule which assigns to each x a unique y, right? So that's a function definition for a function. So you have an input which produces unique output. In case that it produces non-unique output, it's not a function. It's still a relation, but it's not a function. Now we have, there we go. Hello, it's my radio voice. So a function z equals f of xy. So a function z equals f of xy is a rule which assigns to each point xy in the domain a unique value z in the range. A function equals f of